Hello everyone. Today I'm going to make a die similar to a dimple die to countersink a piece of sheet metal for a drain for my bandsaw flood coolant system. So we'll start by putting the part in the 3-jaw chuck so we can face it off. So we're going to start by setting 0 on the DRO so we know how much we're taking off. And I like to take light skims just to square up the stock. I'm not really trying to take off any material here, just to make a nice square surface. So the surface finish on this was okay, not great. I don't know if the insert is, getting a little worn or damaged or whatever, or if it's just the steel or the speed or whatever, but it's not bad. So good enough for what we're doing. So I'll flip it around and do the same to the other side, and then we can start the drilling and boring operations. So we're going to start by zeroing out the DRO again, just so I have an idea of how much I'm taking off and where I'm cutting. My lathe came with a DRO, and I tend to use it a lot. I'm not sure how well I would do if I was just working with dials, but I may have to try it someday just to see. All right, so now I'm going to center drill, enlarge the hole, and then drill it out to its final dimension of, I believe it's 13/16 is the size of the hole for the other part of the die that fits down inside it. Okay, so now I'm just going to chamfer this side, and then we'll flip it over and machine the concave part of the die. So now I'm just going to put a small chamfer on this outer edge, and the hole there doesn't need it because that whole area is going to be machined in and recessed for the other part of the die to press the sheet metal into. So now I'm going to set up a boring bar, but I need to adjust my tool post so that it's square to the chuck or the workpiece. So I'm using a little trick I learned from Blondie Hacks, using a 1, 2, 3 block against the chuck to square it up, and then I can tighten it down, and works very nicely. Okay, so now I've got the boring bar installed in the tool post holder, and I'm going to zero out the DRO on the X and Y axis. It's a little more critical for this operation. And now I can start boring out the recess that will correspond to the other part of the die that the sheet metal will be pressed into. It'll be flat bottomed with a 45-degree chamfer on the outside edge. Okay, we're getting pretty close, so let's do a test check and see how much more we have to go. All right, let's check the fit. And it fits, but I think I want to take a little bit more off to account for the thickness of the sheet metal. All right, one more check. And that looks good. So now we can chamfer the inner hole and then work on that 45-degree bevel. So I apologize. I apparently neglected to record the part where I machined the bevel on the inside of that, um, the female part of the die. So now we're getting started on the male part of the die and facing it off and then turning down the diameter until we get to the larger part of the 45-degree bevel, at which time we'll machine the bevel into this part. We also need to drill a hole for the bolt to go through that's going to be used to compress the dies together. I misspoke earlier. I forgot that I'm still working on the non-compression part of the die, so we just faced it off, drilled a hole for the bolt through, and now we're just going to chamfer this edge a little bit, and then we can flip the part around and start working on the part of the die that actually compresses the sheet metal. Again, setting our zeros on the DRO, and now we will face off this side. And now let's check and make sure that I have enough room, enough clearance here for the shaft that's going to go down inside of the other die for alignment purposes. Looks like we do, so let's cut it down to size. Somehow my x-axis on my DRO got changed, and I was taking way too big of a cut for this little lathe. Alright, so I've got to take off 0.028 off of the radius. Don't think I moved. Nope, I didn't move. The cross slide. 0 out. 0 that out. X out. Which I think what I'm going to do is 0 the X out at the stop. That way I know that's where I just need to go to 0. Okay, so I'm going to take off 0.028. So let's take off 0.01. 10th out right now. Ooh, I think that'll do it. Okay. Okay, now we have to cut the profile on this face to be the opposite of this, with clearance for the sheet metal. Alright, gotta pull this out of the chuck a little bit. this running true. Whoa! Shit. Look at that, people. I finally did it. Luckily, I didn't turn it up all the way. That's why they say never leave the key in. All right. It's not out too much. There we go. Now I'm setting the compound to 45 degrees so I can cut that 45-degree bevel. Alright, so I forgot when I started making this, or doing this operation anyway, that there is a flat right at this edge. So it goes in perpendicular to this shaft and then comes at a 45 before going over. So I just did the math and I figured out I need to make that edge of that flat from this face 0.106 inches in, and it needs to go in this direction 0.069. So I should have my that angle is off, so I need to readjust my tool post. Turn it this way. Re-zero my self. This is one of the 0 points. And the other one is this piece. So I need to And so the part is done. And here's a photograph of the completed part with the bolt and nut that are used to clamp it together to deform the sheet metal. The part that goes through the hole that this is intended to recess is this stainless steel thru-hull adapter for a boat. And here is the actual piece of metal that the thru-hull is going to go through, and you'll see this part put together and everything completed in a video coming up on modifications I'm doing to my bandsaw. I didn't realize that it was going to, didn't think about that it was going to chip the paint, but there's really nothing I can do about it, and it doesn't really matter. Anyway, thanks for watching, and if you would do me a favor and subscribe to my channel, I'd appreciate it. Take care, everyone.